Hello and welcome to a tutorial in Solidworks. We are making fidget spinners. You know, the toys from 2 years ago. This is a companion video to my design and 3D printing video on the same topic. Probably a link will be popping up here in a bit, but let's get to it. This is Solidworks. This is a coin fidget spinner, so I'm using coins as the weight and just a standard bearing for the center. I will put the link to the bearing down in the description. But let's get started. Start a new part. Start a new sketch on the top plane. So we're going to start here. The first step is starting with what you know. So I know the size of my bearing. The center circle is 0.315 inches. And the outer circle is 0.866 inches. Obviously adjust to the particular dimensions of your bearing, but I believe these 608 bearings are pretty close to being uniform. I'm going to go ahead and extrude that 0.28 inches, select the top surface, do another sketch on top of that, and actually I'm going to offset this edge by 0.004 inches. And that is a really tight fit for the bearing itself. We're going to be constructing this in such a way that you can adjust these different circle offsets to get a tighter or a looser fit for all these circular objects. So if you wanted to have a looser fit for your coins and glue them in, you could do that, or you could have a tighter fit and really dial it in so that it just presses in. So we'll draw our first appendage off to the left here. Leave that undefined for a second while I draw a representation of my quarter, which I'll be placing in the top and bottom surface. And then let's go ahead and dimension that. Oh, I got really close to an inch there. I'll draw a circle to that edge as well, which should be driven, but let's see what its dimension is. So that's about 3.5 inches in total diameter, which is a little big for a fidget spinner. It depends on the size of your hand, obviously, but let's draw that back, make that line construction geometry, and go ahead and just make it an inch for funsies. I'm going to be offsetting this quarter. So this is the actual quarter size, so I'm going to offset that by 0.008 inches, just a little bit more than the previous one. Make those both construction geometry. Select the outer and offset that by a generic thickness of plastic. I use 80 thousandths of an inch pretty generally. That's really close there, which is going to be just fine. I'm going to offset this line that represented that offset for the bearing, the same 0.08 inches. And now actually that works just fine. I'll be able to trim that out and have a nice solid structure there to grab onto. So anyway, to the circular sketch pattern. 3 instances. And that is looking pretty good. So power trim away, connecting all these geometries like so. And that should be a shape that we could extrude. So try that. Features extrude the other way. I'm going to go with the same 0.28 inches. That'll be our first coin pocket. Go ahead and draw the underside coin pocket, which I'm going to make a slightly larger offset. If your printer was good enough or you had better skills in 3D printing, you could actually do this in one step with the same offset. But the way I'm printing it, there'll be structures underneath this surface that I get kind of janky, and so I like to just make a larger offset for the bottom. That's worked for me. So same first circle, but different offset. I wrote it down. Let's go with 0.016 inches. And features extruded cut, the same 80 thousandths of an inch. So pocket on the top, pocket on the bottom. You could stop here, or you could do another trick to increase your weight. So physics, something about physics, angular momentum tells us that the more weight you have on each appendage, the better for spinning. So I like to increase the weight wherever I can. So you can hide another quarter in between, you can hide another coin in between the two quarters. I like to use a coin that's a different diameter, smaller, just so that it's easier to locate them in the geometry, or in the frame, I guess. So select that surface, sketch, sketch, circle, circle. I'm not sure what that line is. Oh, sorry, that mark, but the real circle I want, center point I want, is right here. The diameter of a nickel, Wikipedia just told me, is 0.835 inches. And I'm going to actually offset that by just, 10 thou, a little bit more. We'll do 12 thou. So that is for a nickel. The base geometry is still a construction line. And features extruded cut. We'll just do a through all cut, just so. And the rest becomes pretty easy. You would select those 3 cut extrudes, perform a circular pattern, select the center circle that you're revolving around, and make the degree measurement 120 degrees because math. Hit OK, and there you have it. This is sort of the most basic spinner you can imagine. So right now I'm going to show you how you can back up to just after this first step and add a little personalization and some flair. So there's a lot that you can do here. My favorite one I think I've done, and maybe I'll pop up a picture of it here, is doing a sketch on this surface, selecting the polygon sketch tool, and keeping with the default hexagon shape, just dragging it to the left. You'll definitely want to, well, the only rule with this is to make it radially symmetric around the origin. So I do believe you could actually locate this just about anywhere and have it be balanced in terms of how it spins around that origin point. For my part though, I really like just this version where I take those 2 vertices and make the horizontal relationship like so. And you could obviously define this just however you want to your heart's content. Let's do 1 inch. I will select everything but that circle and offset that a generic thickness of plastic in the other direction, reverse. I made a mistake. So when I offset that, you want to untick making the base geometry construction so that you can extrude this upwards. A very simple sketch, then you could extrude that sketch. The same 0.28 inches, or you could go ahead and in this direction say up to surface. So this is kind of a best practices thing, but this way, if you ever wanted to adjust the overall thickness of the geometry, it would adjust this, at the same time. So as you can see, that sort of gives you a very different sort of look and feel. This is the basic, and this adds just a little something to it. The great thing about this is you can really adjust that sketch really easily to get a different feel altogether. So instead of this, I'm going to select it all and delete it, make a circle about the same, same size, and offset that a generic thickness of plastic. Backing out, you get something a little bit different. I'm going to go ahead and do a chamfer on the top and bottom just to clean it up a little bit, make the edges a little less harsh. I like chamfers for 3D printing. The 45-degree angle works well, I think. And I'll just dial that in until it is happy. And here's it without any feature and with the circle feature. So let's do one more. All right, so this is just me playing around a little bit. Took a bit of time, so I sped it up. But basically, I'm just trying to create this sort of radially symmetrical angular feature. Took a little time, basically, because I didn't know what I was doing. I was kind of making it up as I go, and I screwed it up a few times. But with a lot of things, you sort of find it along the way. And I eventually got there. Okay, so now I'll make the center holdy bit for this fidget spinner. I've experimented with a lot of different designs that locked in together. In the end, I went with a simple press fit, just like the bearing into the outer frame. And I'll make that real quick for you. New part. On the plane, sketching on the top plane here, I will begin with a circle. That'll actually be the one that presses down into the bearing. So we'll start with 0.315, the dimension of the bearing. Select it, offset that by 0.04 of an inch, making the base geometry a construction line. And we will features extrude that some dimension, 0.138. On top of that, we will make another sketch with yet another circle. That's going to be a little bit larger, and this will help it and this will act as sort of a stop so that you can't overpress the center bit into the bearing. You want the surfaces to not quite get too close to the bearing itself, or it'll interfere with the spin. There's probably a better way to do this, but this works for me. I'll make this circle 0.4 inches in diameter, and then I will go features, extrude that, 0.05 inches. So far, so good. One more sketch, one more circle. And this will be the actual part you see, or the beginning of it at least. I'll make it 0.95 inches. I don't know why I didn't make it an inch, but this is what I'm going with. And features, extrude that 0.08 inches. Now this will make a very flat surface. You could print it like this, the easy way, so this surface is facing down. I like to have a kind of convex surface to, I don't know, give you a little bit something to grip with. Frankly, or a concave surface works pretty well. I've done both. What I don't like is a flat surface because you get sort of an ugly finish. So I was really prioritizing the aesthetics of this finish, which is why I'm doing this next step. Feel free to skip it. On one of the side planes, in this case the front plane, I'll make a sketch from the center point of that circle out to the edge, a line that is, and then a line vertically. I'll define that to be just a little bit, 0.05 inches. And then I will take a spline, I'll use the spline tool to connect those two lines. To get a slightly convex surface, I'll grab this part of the line and this little handle and stick that up there. Actually right-clicking on it and making it horizontal. So this you can sort of adjust as you will to get sort of whatever you're going for. That looks good enough for me. I will take this sketch, features, do a revolved boss with the axis of revolution being this center line here. And I believe that'll work. It sometimes looks like you didn't do anything. And all you can see is like a subtle shading difference because it is such a very subtle feature. But obviously if you do a section, you can see it there. Come on. Very subtle. The last few things I'm going to do are add some... So to finish this off, I'm going to add a fillet to the top surface of 0.05 inches or whatever. If you make it a little bit too aggressive, you end up with a very sharp kind of point here, depending on how you drew that spline, which can be hard to 3D print. So I'll leave it at 0.05 inches. And I will make a chamfer on this face, just to help it fit into the bearing as it starts. So 0.25. Let's go ahead and make it a little bit more extreme. 50 thou. Make it easy on us, right? So to get this top surface looking a little better, I do have to print it the hard way so that we will use supports to get to this surface right here. But in general, that's worked really well for me, and I haven't had any problems. So that's basically it. As geometry creation goes, it's pretty straightforward. But again, these things are still fun. So please, if you had any questions or comments, or most importantly, if you see me doing something stupid, please leave a comment down below and I'll try to respond. You guys definitely know a lot of stuff and hopefully you can help me improve. And if I help someone improve along the way, all's the better. So that's about it. Until further notice, I'm Chris.